SDN Tech Forum. This is SDA Bootcamp, and we are making a very good progress here. So in last video, we finished building underlay by LAN automation. Now, so we have our border node available, we have our edge nodes available. Now it's a good time to start the journey towards fabric. So before we start building our fabric, let's understand what is a fabric network, right? So this is a little bit different concept from traditional networking. So let's understand what it is. A fabric is a logical grouping of devices that is managed as a single entity in one or multiple location. So you can think of fabric as a branch office, a corporate headquarter, or within a corporate headquarter, you can have like multiple fabrics. Having a fabric in place enables several capabilities such as creation of virtual network, which is VRF, and user and device groups, and advanced reporting. So you can have reporting strictly applicable to the fabric for a fabric. Other capabilities include intelligent service for application recognition, app experience, traffic analytics, traffic prioritization like QoS, and steering for optimum performance and operational effectiveness. A lot of things here, but you will understand when we start building the actual fabric. Cisco DNA Center allow you to add devices to a fabric. That is a part of workflow. These devices can be configured to act as a control plane, border, or edge nodes within the fabric network. All right. So these are the roles played by devices, and based on role, they get different configuration. A fabric domain may consist of one or more fabric sites plus a transit site. So always make sure that you have at least one transit, because fabric is self-sufficient, but at the same time you want to reach outside the fabric to access various services, and that is done via transit. Multiple fabric sites are connected to each other using transit site. A fabric site is an independent fabric area of with a unique set of network devices. So within a fabric site, what you can expect? You can expect control plane, border plane, edge, WLC, sometime your ICE or PSN, etc. Different level of redundancies and scale can be designed per site by including local resources. So within fabric, you can override fabric settings like DSCP, AAA, DNS, etc. at per fabric hierarchy basis, or you can inherit it from the upper hierarchy. A fabric site may cover a single physical location, multiple location, or just a subset of location. SD access transit and IP-based transit are two types of transit supported today. And we will understand the difference when we start building the fabric. Again, this is pretty much the same thing. This is the guidance how you should build a fabric: single location, multiple location, software subset of location, etc. All right, and this is basically fabric assurance. We will come and look at this once we finish building our fabric. So now let's go and start building a fabric. I'm going to pause the video now and go to DNAC, and we'll start building the fabric. So thank you. Here I am in Cisco DNA Center documentation, and let's look at provision fabric network. I highly recommend you to go and read this document. And now let's come back to DNA Center. We have two hierarchy created, East 01 and 02. Within East 01, you can see I have IP addresses pool configured. In the fabric site, you can see today we have 0 fabric site, 0 fabric zone, 0 fabric devices. So there is nothing. It's all clean slate. And fabric zone is a subset of fabric. We will talk about this in advanced video. But for now, just focus on building a fabric. How you can build a fabric? You can either build a fabric using the workflows, what you can see here with tips and workflow. Let's look at all the tabs. So in virtual network, again, you have a couple of workflows available to get you started very easily. But nothing is there, everything is count as 0, that means nothing is configured yet. When you go to transit again, you can see I do not have any IP based transit, I don't have any SDA access transit, and this is the educational workflow. If you click on next, it will tell you about what you can do at this page and some concepts. So interactive help. 3 type of transit options available today: IP based, SDA access, and the third new one is SD-WAN access transit. So you can have similar uh, policies across your SDA and SD-WAN. That's the latest addition to that. All right, what I'm doing, I'm like navigating you under SDA access, various tabs to show you that there is nothing and how we are going to start from scratch. This is the view. There are like, this is a table view, this is the geographical view. Whichever view is works for you, in easy to comprehend, I advise you to use that. I'm good with the table view actually, but in widget or thumbnail you can have workflow available also. So from the table view, I want to say create fabric. Within site location, you have to choose which site you want to make as a fabric. So we have all our devices in East 01. I selected that. Wired endpoint data collection. This is coming by default. That means all the devices, they will have telemetry settings enabled for wired data. So you can take a pause, read it, and you can see what we are talking about here. So these are the some default by default configuration will be pushed when you create the fabric. Authentication template, we have talked about it. We will create a close authentication fabric. We don't want to create any fabric zones now. So we will just go with the default and say set up fabric zone later. And this is the fabric zone. Fabric zones are optional. They reside within a fabric site and can only contain edge node and extended nodes. Fabric zones are used only select virtual network and anycast gateway are provisioned to edge device. So this is like a simpler or a small scale provisioning of a fabric. We don't want any fabric zone now. So let's go ahead with the standard configuration. But in case you want to create a fabric zone, what you have to do, you have to select one or more areas, building or floors to enable as a fabric zone. Let's not do that. Go ahead. And this is the summary fabric site. I have selected my hierarchy 01. TDL, wired TDL will be enabled. Authentication template is closed. That's it. And let's see what is the configuration being pushed on the devices also. Okay. As you can see, I have just one BGP configuration, BGP neighbor, and 2 of the neighbor I have configured, but they are not up. A relationship is not established. Let's look at what we have on our border node. This is going to be our border node. And as you can see, it has only one BGP relationship, that is in IPv4 global address family with Fusion. And that is being used to exchange the shared service information. Okay. Let's see what we have on edge switches before we actually go ahead and push enable configuration. As you can see, no BGP, no Lisp on edge switches. So this is kind of like a pre-check. All right, now we have an option to deploy. Once we hit deploy, your fabric site was created globally. We expect provisioning process to take 2 to 5 minutes. That means during that time, it is going to push the configuration to required devices. And initially you have seen that it is only going to push some wired TDL. And if you go to workflows, you can see one of my workflow should be active, and these are like different workflows. Some the interesting thing with workflow is if you happen to start any one of the workflow and exit, it will be there. It will, and you can restart it. So you can have some stale workflow or previous workflow. But let's go to the task, and here you can see create fabric site. Okay, no devices were configured, and you can see my deployment was successful. We can expand each and every intent and see what is going on there. So fabric validation is successful. User intent to network intent is successful. Let's keep on checking. So this is very nice that within task you can expand and see what DNAC is actually doing. Okay. Now let's again go to provision fabric sites. Now you can see I have one fabric site created, but this fabric site has no devices in it. It's just the site hierarchy which I assigned. So don't think that automatically all the devices who are part of this site they'll become part of that fabric. No, that's not true. We have to go ahead and manually add them, assign them a role. So right now only the site hierarchy is a part of fabric. At the same time, let's go ahead and create transit, because we know that this fabric site will be communicating outside world. So we need a transit for that. There are two options available: SDA access. Within SDA access, you have Lisp with BGP and Lisp with publish and subscriber. This is the new addition. Lisp pub sub, accelerate network convergence, simplify network things. So it simplifies the configuration. So if you're a greenfield, I would say go with Lisp pub sub. But for this video, we are just going to stick to Lisp and BGP for our we are not actually even using SDA access transit type. Sorry about that. Because SDA access is completely VXLAN, we will go with IP-based transit. That means anything leaving our network, the VXLAN encapsulation will be removed, and they go outside just as a native IPv4 packet. Okay. But if you have multiple fabric and you want a seamless communication between them, SD access is a good choice. So you don't have to remove, encapsulate and de-encapsulate VXLAN. It can be native VXLAN end to end. But for us, IP transit is good because this is a small scale lab network. All right. Just want to show you, wanted to see what is the ASN number of the fusion router where we are going to create the IP transit. So our transit is AS6501. Okay, so we are putting the placeholders and we'll put actual interface in next step. All right, so we have one fabric site, one transit created. As you can see, I have all the devices visible here, but they are not part of fabric yet. We have to choose and assign the fabric role manually, and let me rearrange the video, rearrange the devices so that we know the communication flow. So I'm going to select GBR, the device with the hostname GBR, and toggle the node called border, and we'll say enable layer 3 handoff. So this will be my border node, and within I can have multiple border, and you can assign a priority to each border. But in this case we have only one border, and we'll leave the priority default at 10. So you can load balance in case you have multiple border. Either you can have 10-10 priority for both of them, or you can have a 20 and 10 and make one primary, other secondary. All right. And then I'd say default to all virtual network. So this border handoff will be default for all virtual networks. I can have more than one virtual network. You will see I have actually two virtual network, one for border, one for corporate VN and one for guest. And at the same time, I'm saying do not import external route. So what we are trying to do here, we are trying to make a BGP connection per VN with Fusion. In simplicity, that's what we are trying to do. We will not import any route from outside world within this BGP. So you are applying a route map which will deny any routes coming in. All right. And what is the transit site you are going to use? I'm going to use IP Transit Fusion. And for that, we need a subnet. So this is the subnet that will be used for my BGP connections. So the IP addresses will be used from this subnet. I haven't assigned an interface, a physical interface. So to the IP transit network, let's do that. Let's see which interface from border is going to Fusion. As you can see, I have a couple of interfaces, but I'm going to use, some are just connected where it's nothing configured. This is a labs section, so you can ignore that. Just look at 10 gigi 101. As you can see, this is a trunk port going from border to Fusion node, and that is the interface we are going to use for all our BGP peerings, and we will have a BGP peering per sub interface or per VRF. All right, right now you can see I don't have any virtual network and other things here because we are just going to assign the interface to IP transit. So this is very much order of operation, right? As you can see me struggling whether I should create virtual network first or IP transit first and all those things. So please keep in mind or the key takeaway from this video is that you have your order of operation, right order of operation, so that you can build your fabric seamlessly. So what is the problem here? As you can see, I know what interface I have to select, but I do not have any VN information, virtual network information. Hence, DNAC don't know how to create sub interface. All right. These are the VLANs you can use, as you know, some standard reserved VLAN plus some additional VLAN which is reserved for DNA Center. All right, so as you can see, my workflow has issue. I cannot toggle the switch and make this a border node because my IP transit is not ready. So I should go back and fix the IP transit information. And for that, I need virtual network. So let's go to virtual network. As you can see, I have my virtual networks created here, corporate VN. Now you can see I have to just go and say add to the fabric. So this we created the Anycast gateway and virtual network in earlier video, but now we are making them part of corporate fabric. So now you will see that if I try to go ahead and add this switch GBR as a border, I should be able to do that. Right, some enhancement available in this release, and because of that I'm seeing this banner. And these are the enhancement: layer 2 flooding update, layer 2 access control list. And we are not going to deploy this enhancement. I'm just putting that in our screen, on my screen, so that you can go ahead and read what is coming, uh, what are the new features dropping in this release. Extended node behavior, layer 2 flooding is very useful when you have extended nodes in your network. For now, I have a small network which is doing a layer 3 access, so we don't need any of this new enhancement. All right, let's go back to the main agenda. Select the node, toggle the switch, try to configure it as a border node. We know what is our local AS, and in GBR IP transit, select the network, and now you can see I have my virtual network available here because we added that to the fabric. All right, please enter a valid VLAN ID. So you need to specify a VLAN ID. So in earlier releases, this was like automatic or somewhat random. Now DNA Center is giving you complete control on what VLAN number you want to use, so that you can have fusion configuration created beforehand. All right, and this is the address pool from which we are going to pick up the IP addresses and create BCP configuration. All right, this node is going to serve only as a border. So I'm going to just select as border. You can also enable multicast, and you can see various information in different tabs. So this is the fabric related information. We are not enabling any multicast RP, and yes, some other things you can also check. All right, it is marked as BN, that says border node. If you want to make any changes in the configuration, you can always click configure and make changes, or else you can click on detail and see what information it is going to use to prepare the network intent or network configuration. All right, let's look at the control plane now, because we want this to be acting as a border and control together. So let's see what we have as a control plane. All right, same configuration, same thing. As you can see, just select the pool, IP address pool, border WAN. So this is the particular subnet which will be used for BGP configuration. And I think I'm repeating here, but the whole idea is we want to assign two roles for this device. One is border. Border node is involved configuration. It asks you for IP transit and another thing. Control plane is easy to enable. All right, so single device holding two roles, border node and control plane. This is the topological view. Sometime it align themselves, which gives you a wrong picture. So you can always create your own custom view. So one final time, we are going to see what the uh, things looks like, and we'll simply say add. I'm just hovering over it so that you can read. If you're not getting it hands-on right now and you would like to see what are those information tabs are, I'm just hovering over it so that you can read through the information. All right, let's not wait. Go ahead and deploy this. So once again, you have three options. You can deploy now, later, or just generate the configuration and see what will be the configuration look like, what is the configuration which this device is going to receive from DNA Center based on the workflow what we executed. And the workflow what we executed is making this device a border node and control plane node. So as you can see, now we have VRF definition created, one VRF definition for corporate VN, because that's the VN we selected. And as you can see, VLAN name is 3001 because we chose that. And look at interface VLAN VRF. So it is now part of VRF corporate VN, and it has an IP address 19.1, which is picked from the subnet what we chose, right? There are a couple of prefix lists defined, which say that, okay, this subnet, the handoff subnet is permit, but everything else is denied from outside. And now you can see the BGP configuration here and Lisp configuration. On Lisp configuration it is getting because we enable it as a control plane node as well. So this is the complete configuration. I'm not going to deep dive into Lisp. We have a dedicated video talking about Lisp technologies. Please go and watch that video. If you have any questions, write it down in the comment. By default, a border is designated, and this is from documentation, designated as external border. So there are multiple roles for border also, external border, internal border, and so on. By default, every border is an external border, wherein it acts as a gateway to all unknown traffic without importing any external routes. Okay. And when you define your border, sometimes you may get confused that what I want to do I have to check this box or that box? So please read this this document, add a device as a border node, and that will give you a good guidance. In our network, our router is, our border switch is an external border. That means it's a gateway to any unknown traffic. All right, so now, we have seen the configuration. We will go ahead and deploy. As you can see, provisioning device is in progress. DNA Center is actively pushing those configuration what we saw to the device, and success. Provisioning detail again, the complete workflow, how DNAC perceived your intentions, how it is actually used the information what you provided, like VLAN number, interface ID, and how it converted them into network intent. And again, as a part of provisioning, since this device has a template associated, it tried to push the template, but since the template was already assigned, no new action been taken. Okay, this is the summary. Configuration operation will be add password, add DNS, VLAN configuration, VRF configuration, Lisp configuration, BGP configuration, etc. Okay, so some housekeeping of DHCP, DNS, AAA, plus the new intent. Busy screen here. As you can see, a lot of CLI capture. Not everything is because what we wanted to push, because DNA Center, every time it provision it or it get a trap, it runs bunch of show command. That's why you will see this screen is very chatty. But overall, the configuration what we saw is been already available on device, and we can verify that using pipe command show run section router Lisp. As you can see, we have the Lisp configuration on border router. Now let's check BGP. You can see we have additional lines of BGP configuration or VPN v4 configuration. Here you can see we have 19.2, which is trying to pair with remote VLAN 3001. show IP BGP. Since we have VPN v4, we would like to see VRF configuration. Okay, let's do all summary. As you can see, it was easy. Show IP BGP VPN v4 all summary. 19.2 is in active state. So we have BGP configuration available on this device. Maybe on Fusion side, the configuration is not in place, and that is why the status is not established yet, which is uh, evident because I have not configured anything on Fusion yet. All right, so now we will go ahead and apply static configuration or manual configuration on Fusion. You could have done that before, even before deploying the fabric, but let's do it now. And this is pretty simple configuration. I'm just going to define one new VLAN, then assign an IP address to that interface VLAN, and then put the BGP configuration. That is it. Just want to make sure what is the IP address. So the first IP address been chosen at border side. So we are going to use the second one. Okay, interface is defined. Now let's put the BGP configuration. Mind it, line protocol on interface 3001 is still down. Okay. So on Fusion, we have interface configuration, we have BGP configuration. Let's see what is missing for this BGP peering to come up. I think some of you already guessed what is missing. Okay, now let's try to ping the other side. 192.168.19.2. So we cannot ping 19.2. Hence BGP configuration will not come up for sure because interface is down. Let's see. VLAN 3001 is down, protocol is down. All right. So as you might have guessed, there is no VLAN 3001 here. We do have interface VLAN 3001, but no VLAN DB 3001. And as you can see, the interface going back to border is trunk, and that allow everything. So what we have to do, we have to simply create the VLAN. And this is the typical mistake sometimes network administrators or network engineers make. So they have all the configuration defined, but they forget to create the VLAN. And a VLAN, active VLAN in your database that will help you bring up your interface VLAN, and only if your interface is up, you can apply any kind of configuration to that, right? So now our interface VLAN 3001 goes up. We should be able to ping. Before we even try to ping, we can see neighborship to 19.2 is up. So our border is successfully handing off to Fusion. And every time I come to topological view, I see the default view where the Fusion is down. So I want to create my own view where I can see it properly. So I created a view and named that as a custom name. All right. Now, finally, we can enable or add edge nodes to our fabric. We have two of them, edge 3 and edge 4. This is quite simple. Just have to enable edge node. No need to do any transit configuration or select any VN and other things here. It's pretty simple. Just go ahead and deploy. We'll watch on device CLI itself, on device console itself, what configuration is being pushed. So let's clear the screen. Same thing we are going to do here. It looks clean. Let's go back and hit deploy. Again, you can do 3 actions. We will first generate the configuration preview and look at the preview together, because it's much cleaner to look in the preview than the device console itself, because device console itself sometimes tend to get chatty. Right now the task is in progress. And there are some nitty-gritty detail about how DNAC provision the devices, how it require netconf lock, how it pushes the configuration, how things are different between a Cat9K versus WLC, and we will talk all about that in our advanced videos. But this is the configuration DNAC will push when you add it as a device. You can see a lot of templates it is pushing, service template, and those service template has tied up with some class map, policy map, and etc. A lot of macros are going into the box. This is IBN 2.0 configuration. If you are not familiar with IBN 2.0 configuration, look out for upcoming video where we are going to break down this complex looking configuration and explain you chunk by chunk what does that mean. For now, as you can see, we have a lot of templates created based on how you authenticate your devices. One of the template will be in use. So in our bootcamp, we have close authentication selected, and within close authentication, we will be doing either .1x, we will be doing map, or sometime the guest authentication. So all those macros are available, but they'll be come into effect only based on how you are authenticating your end host. So you can see this template wired .1x closed auth. It has all the .1x and other configuration. They are grouped as a template and will be called in a policy set. And then of course we have the router Lisp configuration, because now we are talking fabric. Whenever we talk fabric, it's all about Lisp VXLAN at a data plane and Lisp at control plane, right? So quite a long or verbose configuration here. I just try to copy and paste it somewhere locally so that we know that what is the configuration we are pushing in each step. it maybe comes handy when we try to just take a deep dive into each and every step. Okay, task is submitted. So we have reviewed the configuration. Now let's deploy this in actual. Task is submitted. We can go back and check the status of the task. You can see it is trying to provision the device H3 and H4, and this is the provisioning detail. Again, it is telling you the workflow, what you mention as a part of the deployment, what validation being made, and how DNAC uh, translated that business intent or workflow intent into network intent and model the configuration. This is a summary, very good summary of provision details. Again, some repeating job like device controllability, but after that you can see add Lisp configuration as IBN service configuration, identity based service configuration, add interface template, etc. Yeah. So two key things it got from this task is Lisp and IBN configuration. Of course, VRF information as well. So now we have successfully built the fabric. Within fabric, we need three key roles: border node, control plane nodes, and edge nodes. Essentially now, at this point of time, we have all three of them. And sometimes it's difficult to find trace where DNAC was pushing the configuration, but this is the complete showrun looks like. Yeah, running checks from multiple angles, like from DNAC, workflow, from devices itself. Sometimes it lengthen our video, but it comes handy. It gives you like a full picture. All I wanted to show you is the IBN configuration on device. Now you can see we have one fabric site, we have three fabric devices, one control plane node, and one border node. The complete summary is here. You can see all the fabric tasks here as well. So time series of your fabric task, whatever fabric related task you initiated, you can see on your timeline, which is pretty cool. So if something goes wrong with your fabric, you can quickly come back and see what was the last task performed. This is the nice view. Again, you see the fusion going back down, and I have to pull it, or maybe what we can do is just change the custom focus to go to name it that, but that view is loaded. So what you can do, you can make this custom view as your default view as well, so that you don't have to load it every time. Same thing, custom focus. Let's load that view and see what I was missing. I was missing that star, because until or unless I click on that star, it is not going to be my default view. Now, so I clicked on the star, the custom view is my default view. So some small things which you tend to miss. The more time you spend on DNAC screen, you will learn those subtle differences. Authentication template is a closed authentication. As a part of that, we have BPDU guard enable on our devices. So this is a recent enhancement. Please read through that so that you can protect your root bridge in case you have any extended nodes. All right, these are the port assignment. By default, all my ports, they are in close auth mode, but you can manually select the port and maybe assign it to open authentication, no authentication, or something else. Right, these are the complete list of VNs what we created earlier. So we got default and infra by default are part of system provisioning, and two of the things what we created is a corporate and a guest VN. Now you can see my guest is also associated with the fabric. Okay, so we have guest, corporate, and three things created as a part of fabric. Now this is the order of operation I was talking about. Create the virtual network first, because you have seen that when you go to create transit, you need a VN. Then create fabric based on site grouping. Come back to virtual network and add it to fabric. Then go back to fabric and start adding border node, and because that way the VN will be available during handoff configuration. This is quite tricky, right? You have to create the VN first, then fabric, then assign the VN to the fabric, and then continue going with the fabric configuration. Just to summarize. All right, and I'm just going to show you that one more time here. If you want to make any changes, you can obviously go back to that and modify configuration. And right now, what you can see, I'm enabling 3 more sub interfaces. So earlier, we only did a border handoff for corporate VN. Now we are going to do a border handoff for corporate VN, guest VN, and infra VN, because now we are feeling confident about creating fabric, creating BGP configure handoff, right? So let me add all 3 of them. What will happen? Device will get 3 VRF configuration. Device will create 3 VRF interfaces or sub interfaces, and 3 set of VPN v4 BGP configuration. And this is the VLAN ID what we are going to use, 3001, 3002, and 3003. You have to remember this because the Fusion configuration is still static, and you have to make sure whatever IP address being used from this pool, you use the opposite IP address or the IP address from the same subnet on the Fusion side and create your BGP configuration. Every time you add something to the fabric, the color changes into blue. That means it is a part of fabric. All right. So just repeating the task one more time. This time we will do 2 additional VNs, corporate and guest. Why didn't I do that in first place? Because I wanted you to be familiarized with the configuration being pushed. Once we get some confidence, we can go ahead and do task in bulk. Because once you understand what is going on, then it is easy to scale. Now you can see in configuration preview, edge devices are only getting the additional Lisp configuration, VRF configuration. That is it. So just like corporate network, now we have another VN. And GBR is one who is going to additional configuration in terms of VLAN, in terms of VRF, in terms of interface VLAN, and BGP configuration. So here, border node is doing heavy lifting. Edge nodes are pretty straightforward or standard. I won't say simple unless you start feeling comfortable with Lisp, but it's standard. So it's easy for us to replace any of the faulty edge node, because they are always going to get standard configuration on demand with provisioning. All right, so this is the GBR configuration looks like. Once again, more line of configuration, but pretty much the repeating thing per VN. All right, let me just copy and paste it for my reference. In case you want this configuration, please leave a comment. I can share that repo with you. All right, so now we are making changes to the entire fabric. Order of operation is important. Please take a screenshot of order of operation when you build the fabric. Keep it handy so that you can build it without any confusion. All right, provision is success. These are the device detail. These are the provisioning detail. Again, same thing, business to network intent translation. Provisioning details summary. This is very nice summary of what happened during this provisioning. One line summary of that what all information been added. Provision fabric site. Now good summary of one fabric site. If you go to that fabric site, that is East01, the topological view is loaded, our custom view is loaded, and now we have GPR and two edge nodes. You can watch the details. Again, we have all three virtual networks available. These are the remote IP. So DNAC allow assign the local IP, at the same time it reserve the local IP, remote IP, because that is being used in BGP configuration. And if you go to BGP, if you validate the BGP, you should see the BGP configuration on your border nodes. However, we have not applied the same configuration or required configuration on Fusion. I'm going to do that so that we will have all the BGP sessions established. Okay, here you can see we have 3 BGP sessions, actually 4 established, 3 for this VN and 1 as in a IPv4 address family. So this completes our fabric creation video, and now we will continue with fabric validation. Thank you very much for staying with me. If you have any questions, comments, please ask in the comment section. Feel free to spread a word, like and subscribe to the channel. Thank you.